Good morning, everyone. This day, we're going to talk about data pre-processing, which is your lab exercise. We're going to handle missing data, encoding, and use feature scaling as well. So, what is data pre-processing? Data pre-processing is the first and most important step before applying any AI model. In engineering, data can be collected from sensors, logs, or measurement, which is sometimes often incomplete or inconsistent. So in your experience, when you gather data, for example, through surveys, some users or some respondents will not be able to answer some of the questions or forgot to answer some types of questions. So we are going to pre-process that data first by using Python and Excel. In Python, we use some libraries such as pandas and scikit-learn, and Excel are useful tools for pre-processing as well. So for today's lesson, we're going to objectives. We're going to identify and handle missing data in engineering datasets, encode categorical variables using Python and Excel, apply feature scaling techniques, which are normalization and standardization, perform pre-processing steps in Python using the libraries pandas and scikit-learn. So once again, what is data pre-processing? It's transforming raw data into a clean and understandable format. So what does it mean is that because programming languages or computers in general cannot be able to understand some, for example, some languages or some human languages. So this data pre-processing will include data cleaning, data integration, data transformation, feature selection or reduction. And this ensures high quality input for AI models. Its importance, example, in sensor logs in mechanical systems may record null or extreme values. So sometimes when we test, no, walang makuhang data or binibigay yung extreme values, which is an outlier. So the problem is that in high temperature readings, sometimes makukuha ng sensor it's Celsius or Fahrenheit interchangeably. So we need to clean that data first for us to feed it into the AI model. And the solution again is to standardize. So yung sinabi ko, we have to standardize the data with pre-processing. So a step-by-step flow would be, 1 is to handle missing values, 2 is to encode its categorical data, and 3 is to use the feature scaling. So a feature scaling is a method to standardize the range of independent variables or features of data in data pre-processing. It's also known as data normalization and is generally performed during the data pre-processing step. So later on, we'll be learning how to use this in actuality. So again, sensors fail. Humans, they skip fields, the system malfunctions. So there will be missing values that are common and can break models. Diba? So the status in encoding categorical data, we can change it as, for example, normal is 0, warning is 1, critical is 2. So when we encode, no, instead of using words, we can use numbers. So machine learning algorithms like KNN, SVM, or gradient descent-based models are sensitive to value scales. So therefore, we need to use feature scaling. Okay, missing values. These are blank, null, or undefined entries in your data set, and they often happen when a sensor fails or a respondent skips a survey question, just like what I mentioned earlier, right? So, for example, these are machine numbers, and machine number 1 gives us these outputs, and machine number 2 gave us a missing temperature value, but the status would be warning. And machine 3 would have a temperature, but the status is also missing. So do we ignore them or do we replace them? We pre-process them. So for the methods in missing values, we drop the row or column when we when few values are missing. So for example, marami ng values ang missing sa row or column na yun, we can actually we can actually drop it or remove it. We can also fill it with median or mean for numerical values like temperatures we saw earlier. We fill it with mode for categorical values like status. And we use prediction models when data is critical and needs estimation. So actually, we can replace the missing temperature earlier with a mean. So here, instead of having a missing value, we use Excel or Python to pre-process them, and we'll have 47.5. So encoding categorical data, these are labels or groups like normal, warning, or critical. Or in different classification techniques, there are various labels. Again, computers cannot process text directly. So that is why, as mentioned earlier, they cannot understand human language, but they can understand numbers. So from the status normal, warning, and critical, we use label encoding for ordered categories such as low, medium, and high. We use one-hot encoding for unordered categories. Example, we have the device type A, B, and C. So example of label encoding is that we transform the qualitative words or these texts directly into numbers, such as normal being translated or yes into 0, warning into 1, and critical into 2. And for categories like one hot encoding, we say normal being 1. Okay, warning is 1 here and critical 1. And then we turn the rest as 0. This is one hot encoding. And this is very common and popular in classification techniques. For feature scaling, let's say you're building a model to predict engine failure based on temperatures such as 40, 50, 60, and the vibration of a very minimum amount, which is 0.01, 0.03, and 0.05 millimeters per second. And these are vibration levels. So temperatures class are very much larger than vibration values, as shown in our example. So a machine learning model may think that temperature is more important just because of its size. So to fix this, we scale all values so they are on the same range. No? So how do we do that? We preprocess. So, for example, machine ID, mo ni siya no, nakabutang sa table. And to do feature scaling, we have two methods. The first one is the min-max scaling. For the formula, actually, we don't need to like memorize them because we already have the system to work it for us. But just to give you a theory or an idea on how this works, the scale value is equal to the value minus mean over max minus min. So this is the original table, right? This is the original table for our data set. And we want the temperature to be scaled like the vibration level. So using the min-max scaling, we have the formula. This 40 degrees can be transformed into 0.0. This 50 degrees can be transformed into 0.5. And this 60 degrees can be transformed into 1. So meaning to say that the features are now in the range of 0 to 1, including this, the vibration, and this. So both of them are now equally important as per the machine learning model. So for method number 2, which is the standardization or the z-score scaling, so we use the value of z equals value minus mean divided by the standard deviation. That is why the statistics in data science is very much important. And you're using the formula to calculate for the temperature, we can get the standard deviation of 10. Standard deviation is that these values deviate from 10, obviously, right? So, yan. And the mean is 50 because we also need the mean and the standard deviations. The value is already here. So using the z-score scaling, we can get -1, 0, and 1 as our scaled na value for temperature. So both methods are really important. So I will give you an analogy. Now, imagine you're comparing the speed of kilometer per hour of a car and the vibration of millimeters per second. So without scaling, that's 80 kilometers per hour versus the 0.05 millimeters per second, and that's an unfair comparison. And when we scale them, both becomes 0 to 1, and this is a fair comparison for machine learning, and you have to remember that.